Okay, so if you're watching this at home, remember that we are using the steps that are up here at the top. And if you, hey guys, listen. If you're going to go back and watch it later, we're using this. And then the other thing is, here's our first example. You can always pause it and you can always sit here and copy this down if you lost it somewhere. Okay, I'm going to work my next example the same way that we did the top one. So I told you that your first thing to do was to assume that I had 100 grams of the sample, right? So we're going to turn all of these percentages in number 4, that's the one I'm going to work now, into grams. So 29.1% of 100 grams would be how much? 29.1 grams of sodium. Okay, I need to do this with every single one of them. 40.5% of sulfur would be how many grams? Okay, and then 30.4% of 100 would be grams of oxygen. Okay, my second step, if I pull this back down so you can look at it, says convert the grams to moles. So this is our old problem. Slide it back up. Okay, I need to go through here and I need to convert grams of sodium to moles of sodium. Hey Hunter, where we get that number from?
We get that number from the periodic table.
Very good. You learn quickly. Okay. 1 mole of sodium. Yes, we caught that on video. Well, your voice anyway.
Oh, yeah.
We caught your voice moment of knowledge on film, sort of. Alright. Now, what number goes here, Hunter?
Wait, let me get it for you. 23.
Very good. 23.0. Okay. Crunch some numbers, see what you get. I didn't say sound like a dog with a fur ball. What do you get? 1.227. Okay, let's do the next one. Now, okay, this is sulfur. So, grams of sulfur per mole of sulfur. Okay, what number have we put with mole forever now at this point? 1. So, 1 mole of sulfur has how many grams?
32.0.1.
Oh, well, now, whether you do 32.0 or 32.1, it'll matter. So, round it up, 32.1. Okay. Crunch some numbers. Tell me what you get. 1.26. Okay. Alright, now, grams of oxygen. Yet again, so if you're watching from home, we just discussed whether or not we should Brinkelhoff this. I think Courtney will. We'll find out. Hey, Courtney, you should email the entire class if you're watching this, because Bryson thinks you won't. Alright, now, we know it's going to be 1 mole. Our discussion earlier was, do we put a 2 there or do we not? And since it's a part of a compound, it's not by itself, we do not. We're trying to find the subscript, so we do not. Okay? So how many grams? 16? Okay, what do you get?
1.90.
1.9? Okay, now, if you go back up, it says, pretend that the number of moles are subscripts, and if they are decimals, they are, then we need to divide them all by the smallest. So what is my smallest number here? 1.26. So I'm going to divide all of these by 1.26. Okay, you can put this in your calculator or you can rationalize that is just about the same. What should it give me? 1. This will give me 1. This does not give me 1. What does it give me?
1.48. 1.5. It's 1.5. That was a good guess.
call it 1.5. I hear 1.5, 1.48, 1.51. I'm going to call it 1.5. Now, okay, check this out. Shh. Up here it says, if necessary, multiply to make whole numbers. Okay, I can go ahead and put it in. Watch this. I can put it in this way. Na1, S1, O 1.5, but I can't have 1.5 oxygen atoms. So what I need to do is I need to multiply every single one of those. Like the easiest way to make this a whole number is to multiply it by 2. It becomes 3. But check it out. If I multiply this one by 2, Hunter? If I multiply this one by 2, then I've got to multiply this one by 2 and this one by 2. So that will make my final answer be Na2, S2, O3. And then there is my empirical formula. Yes? Well, no, but I know that if I've got to multiply it by something. If I go through, like, if I could do the division thing again, my smallest number now is 1. So if I divide by 1, I'm just going to keep coming up with the same thing. If I look at it as I've got to multiply it by something to get a whole number, you would start with 2. You would start with 2, and if 2 doesn't work, you could go to 3. If 3 wouldn't work, then you could go to 4. Like, you shouldn't have to multiply by a lot. The other way that I've seen some of these end up before, I have seen some of them that will end up with like 0.33, 0.33, and, like 0.66. So if I divide all of those, that would be 1, 1, and 2. That would work itself out on the first division. I have seen some that will work out like 0.33 and 1. Okay, well, I can make a third. I can multiply a third by something to equal a whole number. What would you multiply it by? So then that would become 1, and that would become 3. It's usually some sort of, like, one of those flavors. I shouldn't really come up with anything else. Everything usually ends up being a half that needs to be doubled, or a third that needs to be tripled, or on my first division, like this one up here, it just works it out to be like pretty much 2, 1, and 4. Okay, questions people sometimes ask, like, what if it's not going to work out to where you end up with numbers like, okay, well, Miss Houston, what if I end up with like 1.84? Do I round that up? Like, I've never seen it work out like that. It's always closer to a half, closer to a third, or closer to a whole number. You really shouldn't be having to round up more than like a couple hundredths. Does that make sense without seeing many of these?
Yeah. Yeah.
Alright, Gavin, do you have a question?
I was just wondering how close.
Like what I just said?
Be for you to round.
What I just said, like how close do I need to be to just round up?
Yeah.
Okay, like I just said, I should be within a few hundredths. If I'm off by like a couple tenths, then I probably should do some dividing. And usually once you do, like, you're never going to divide more than once. Once you do your first division, you're either in the land of go ahead and bump it up because it's so close, or that's not close, I'm going to have to multiply. Okay? Alright, well, I have 3 more for you to try your hand at this. And I'll give you maybe the next 15 minutes or so to try 1, 2, and 3 that are up here. Okay? Hello?